give a demonstration of some of the changes in NGL from NGL 4 to 5, and I'm going to use this simple NGL demo here, which just draws a basic VAO teapot primitive and does some basic Phong blend lighting on it as a demonstration to show you all the changes. Now, one of the biggest changes in all of this is the way that we're using GLSL version 150. And we'll get to those changes later on in this series of videos. There's going to be quite a lot to talk about. So let's just start with the overall application. It's using Qt, so basically we have a basic Qt application here. We create an instance of a Q application, then we create an instance of main window. The main window class will then create a GL window as a child, and that will take the entire Qt window area up. And this is very simple here, some very sort of easy bits of code handling, key presses and things like that. If you read my lecture notes online, you'll see an explanation of all of this. This is more concerned with the new usage of NGL. So the GL window class here has basic framework, GL Windows constructor, there's a destructor, and then there are a number of methods that are protected, which are basically virtual methods inherited from the QGL widget class. Initialized GL is called once when the OpenGL context is created, and this is basically where we do our initialization of things like shaders and other things. Then we have resize GL, which is called every time the screen changes size, and we'll just make a call to change our camera parameters for the NGL camera, and also we will make calls to the GL viewport command to set that. And paint.gl is where all of the sort of real work goes on. This is our routine that's called every time the update GL method is called to paint the screen, to do our actual rendering. So what we've also got is a number of class attributes here which are storing things that are useful for things like rotation, translation. Stores our global camera, our global transformation stack, some other static things here, and a global light which we're going to use to light our scene with. So if we go to GL window, the constructor here, this is one of the major changes between NGL 4 and NGL 5, is the fact that I've had to inherit certain features from the QGL widget and actually explicitly create a core GL context on Mac Lion. And that's because Mac Lion has two distinct OpenGL libraries. It has the OpenGL 2.0, which contains all the immediate mode and everything else libraries, and it has a OpenGL 3.2 core profile library. And the core profile library under Lion has absolutely none of the immediate mode and deprecated OpenGL features. It's a very small, lean library, and we can't use any of those features. Now the problem is that Qt at present in the 4.7, which is our stable working version, doesn't support setting any of this up. The experimental versions of 4.8 do contain some of this, but I've not fully tested it yet. So there is a new class in NGL called Create Core GL Context, and what this does is it basically goes off and it calls this virtual function, if we're under a Mac, called Choose Mac Visual. And what this is actually a chunk of code in Objective-C, which I can show here. This is sort of hidden away in the NGL library. But what this does is this bit of code, if we're on Mac, it actually makes a call to set all of the attributes here. And you can see this is the call. This is set the OpenGL profile to core 3.2 core, and it sets some other attributes, default attributes and things there. So this is only pertinent to the Mac version, but obviously very important because otherwise we can't use OpenGL 3.2 core profile, and that means we can't use GLSL 150. So this is hidden away from the user because if we're on different platforms it doesn't matter, so this was put into the NGL library to make this work. The upshot is that the call to the constructor of GL window must now have this call here if we're using Mac to create our correct format. If that's not there, then under Mac we won't get OpenGL 3.2 and the shader subsystem won't work. The rest of the constructor is more concerned with setting default values, as you can see here, resizing the screen, setting the mouse focus. So we've got just setting our rotate to false and our spin values to 0. No OpenGL or NGL initialization must be done in here. NGL is very reliant now on having an OpenGL context before it can do anything, because everything's stored on the GPU using VAOs and other things. If there is no context, basically the system will crash. So no NGL calls should be put into the GL window constructor. We need to have a valid context before we can do virtually anything in NGL now. The Destructor, again, this is just going to do some tidying up, remove various things from NGL. NGL quit is part of the init method, and all it really does is it goes off and it will do lots of the tidy ups and things like that that we need to clear out all of our buffers. We can see here that there's an initialization of glue and things like that. Basically what it does, it clears out all the vertex array object primitives, and then it traverses the shader library and it removes all of the shaders that have been created and tidies up after itself. As there is no sort of real texture management or anything else in NGL, that's for the user to use. Any textures and things like that should be cleared up in that Destructor as well. The next thing we will go to, I'll split this into a second video because these videos will get quite large, is we're going to look at the Initialized GL and the loading of shaders. So that's going to come in the next video.